Awesome. Okay. Recording?
Recording.
All right. Welcome, guys, to FRQ2 discussion, frequency of a pendulum lab. So any questions you guys have, make sure you go ahead and put that in the chat, and Mr. Schramm can go ahead and answer. Today, we're going to look at an experimental design question. This should look really familiar to everybody, hopefully, because you did this lab at home back in January to start off first semester. So we thought it'd be a good one to give you some practice of writing a procedure because you have some good background on this experiment. So here we have a simple pendulum.
It's a good deal.
Just give me your credit card number.
I love Goofus and Gallant.
Highlights reminds me of the dentist office. That's where they always had it. But
Okay.
anyway, I digress. A simple pendulum consists of bob hanging.
Oh, Bob.
Oh, poor Bob. From a light string. You wish to experimentally determine the frequency of the swinging pendulum. So when we did our experiment, we were looking at factors that affected the period, and this is acting for the frequency. But what you want to think here as you go ahead and answer this is that you definitely have a relationship here that the frequency is equal to 1 over the period. So keeping that in mind, you're able to measure the period, and then you can take the inverse of that to get the frequency. Okay, so for part A, you just have to check what equipment you're going to need to do this experiment. So to measure the frequency of the pendulum, which I would be measuring the period to obtain the frequency, I would want to have a stopwatch. Whoops. Okay. Now for the rubric, when you go ahead and grade it, it says, and ideally you should have done this already, to determine frequency, all that is needed is a stopwatch. Now this, I find it kind of surprising that this part A is 3 points here. So to figure out if you're going to earn 0, 1, 2, or 3, we're also going to need to look at your answer for part B. So right now, if you just had stopwatch, you get all 3 points. If you had other equipment in addition to the stopwatch, we're going to have to review your answer for part B as well to see if you're using the equipment correctly. That's not going to interfere with using the stopwatch. Okay? Okay, so then let's go ahead and look at part B. Describe your experimental procedure that you would use. In your description, state the measurements you would take, how you would use the measurement to make them, or how you would use the equipment to make them, and how you would determine the frequency from those measurements. Okay, in our lab, this was one of the, you had 3 different factors that we tested. We had you do objective 1, 2, and 3 on our lab, where you first measured if mass affected, and then length affected, and then the angle affected. So for here, if you just want to get the frequency, you should have everything constant in your experiment to measure this. So you should be talking about using your stopwatch to determine the period. So by releasing Bob from a height, and then you could write maybe to go back and forth 2 times for accuracy, and then divide by 2. Would they probably need to do that, or could they just say
That's
over
actually,
that once?
that's actually in the part B description.
It is.
They have
Okay.
to have something saying
To reduce.
how they're going to reduce error. So I always say repeat multiple times. So in this case, you can keep doing the same thing 5 times, or you could just let it run for 5 periods and take the average. But yeah, you do have to have something here.
Okay, so again, in every experiment, you want to make sure that you have multiple trials for it.
And that's consistent with all experimental design questions. When they ask you to write the procedure part, you should include something in there that says something about reducing your error. And the vast majority of the time, I can't think of a time when it's not the case.
Mhm.
It's simply repeat this repeat this multiple times in order to reduce error. It can be one sentence usually, as simple as that.
Right.
You guys do need to be careful about, well, some of you need to be careful and make sure you write enough words. But there is a group of you that writes way too many words. And so like you're like me, I talk too much. But for that error thing, one quick sentence is sufficient on the AP test. So don't do more than that.
Okay, so as we look at how this is scored here, part B, and then we're going to have to go back and review part A as well with this. So a reasonable and complete procedure that correctly measures time and allows for determination of frequency, either by calculating frequency or indicating the correct relationship between period and frequency, or directly determining frequency from the measurements. So frequency is the number of cycles per second. So while that would be hard to measure, you could go about explaining that, but most likely you were saying to complete one complete motion, potentially, back and forth like 3 times, and then dividing the total time by 3 to get the period, and then stating that to get the frequency, you would do the inverse of the period, writing again this explanation of what you would do. Sorry, as that's coming up there slowly. What you would do with that measurement for period, okay? If you checked additional things in part A, like a meter stick and a protractor, in part B, you'd have to explain what you were doing with those. So if you check them, and then if you're going to put it correctly in there, you might state something like, using the meter stick, I would measure the length of the string and be sure to keep that constant for each of my trials. I would also use the protractor to measure an angle and make sure to release Bob, the pendulum, at the same angle each time. However, if you put something about changing the length of the string or changing the angle or changing the mass, then that is going to be incorrect.
Yeah, that you will definitely lose the points on part 1 then. Also, this is probably a little bit more rare, but if for some reason you use the stopwatch incorrectly or you had no idea, if you just randomly chose stopwatch, but you didn't say how to use it in part B?
If you just said to collect the time as the pendulum moves, probably not clear enough.
Yeah, you might not get your points for stopwatch in part A. So
it might be good to
have to
draw
show
a
that you know what you're
picture
talking about.
if you're
it
not
would be
sure.
great to draw a picture.
So, I mean, you could draw something as simple as, here, Bob.
And then make an arrow to the right and an arrow coming back.
And then put that down. For example, this would be one complete cycle.
That would be
drawing
fantastic.
something like that. Okay. And then you could say, I would repeat this 5 times to reduce uncertainty. Okay. So when you look at how this was scored for this part, again, using, where are we at for part B? This is all. Okay. Correctly using your stopwatch, explaining what you're going to do with that time on your stopwatch. Again, clearly stating that if you allowed it to go back and forth more than once, that you're dividing by that number of times, and that if that's how you were using the stopwatch, that is the period, and that you would need to then explain how you would get the frequency from that, by again saying frequency is the inverse of the period.
Yeah. Usually these things might be broken down into a point-by-point type thing, in that experimental procedure would be one of the points, saying what to do correctly as a point and not doing anything incorrect as a point.
Yeah. So one corrective use of the stopwatch, one corrective using the data from that correctly in. So again, now you have to go back and think, if you had checked more equipment in part A, did you use that correctly? You would have to explain each thing that you checked in part A. You would have to explain how you're using that in part B, and it would have to be correct. So if you were making any changes, again, with mass, meter stick, or protractor, then you're going to lose almost all your points.
Yeah.
Here.
I mean, and you could, like, as I read it, you could have the photo gate for some reason. You could use a photo gate as a timekeeping device. There's a way to do that.
Yeah. You guys probably don't know what a photo gate is because we haven't done experiments with them this year. In a normal year, we would, but a way together.
But it can't interfere with what you're measuring either. So, all right, I think we're good there.
Okay, so let's look
Are
at,
there any other questions?
any questions,
Jeremy?
please go ahead and unmute or type in the chat. All right, on to part C. You next wish to discover which parameters of a pendulum affect its frequency. Again, frequency is the inverse of the period. State one parameter that could be varied and describe how you would conduct the experiment. Indicate how you would analyze the data to show whether there is a dependence. This is exactly
Yeah,
what
we should
we
do a lab like
did
this.
in the class.
Yeah.
Okay, so you could choose,
You only have to do one.
yeah, will mass affect the frequency? Will length of the string affect the frequency? Or will angle affect the frequency? Okay, so though you could choose any one of those three.
I had a height one too, which is really the same as angle.
Yeah. So let's say you just wrote it up for choosing would mass, changing the mass affect it, hypothetically. You would, I think they'd have to say independent, dependent variable in there.
It's not a matter of, you couldn't get away without saying it, but it never hurts to be very specific and say, my independent variable would be this.
So if you chose mass and you would say my independent variable or the variable I'm going to determine if it affects the frequency is mass, I would gather masses of known value, or I would have a balance to measure the mass. And then I would, so there you're explaining how you're going to change, how you're going to get the value of that variable, what equipment you would need, and how you're going to change it by putting different masses on the end of the string. You would then state, you would need your stopwatch to determine the period.
And that's going to be and you might want to say that is going to be related to your dependent variable, right?
Which is related to your dependent variable. So how you would get the frequency is to obtain your period from your timing device, and then using frequency as the inverse of the period, you would then have your frequency. To indicate how you would analyze your data, you would create a graph of frequency versus your variable, mass, for example, or length of the pendulum, or the height of release, to see whether there is a dependence by creating your graph and analyzing
Like with an appropriate regression.
with the appropriate regression.
You don't even need
if
to
there
say
is.
what regression it's going to be, because maybe you don't know it's going to be power or linear.
Right.
So the line we always use in AP Physics 1, and we didn't get to do this as much this year, is that analysis part is, I am going to graph my independent versus, or sorry, my dependent versus my independent variable. And then I am going to apply an appropriate regression and see what the relationship is.
And
Done.
that's done.
The 2 sentences maximum. You could even turn it into 1 sentence if you use a conjunction.
Okay. So again, you're just describing how you're going to conduct the experiment. So you do not need to talk about.
You should probably put
your
in something
results.
about reducing error, maybe. You could do multiple trials of things. It can't hurt you.
Right.
I don't know if it's counted in this one, because we already talked about error in the last one.
It is. Wait,
It
no,
is,
that's
okay.
part B. It has it. Part C, you would get 1 point for indicating that choosing a parameter that can be, let me scroll down to that so you guys can see it, part C here, that can be varied, the mass, the length, the angle of release or height of release, okay? And then, so just choosing something correctly here. And then the other 2 points for a reasonable and complete experimental procedure and description of data analysis. Okay, and so that data analysis part again is creating your graph and applying an appropriate regression.
You don't, they're not asking you what the results are either.
Right.
Some of you are like, you might, if you're worried you can't remember what the relationship is, it doesn't matter here. They're just saying, how would you test it? All right, they're not asking you what you are going to find, just how would you find it?
Now I've seen questions where they've done that.
They sometimes have a follow-up question where they give you some data.
But by looking at the formula, you could then draw your answer from it. Okay. All right, on to part D. All right.
So this is the energy one, right?
Yeah. Let me go up to.
Little
there
thinking
for
that you gotta
guys.
do here.
Okay.
While she's opening that up,
Right
let's think. Theoretically, if we're just doing AP Physics 1 and we're thinking of, you know, a closed system with no frictional forces, when does this pendulum stop? In the magical world of AP Physics 1. It doesn't
Never.
stop, right? Potential energy keeps turning into kinetic energy, turns into gravitational potential energy, back forth, back forth. But we know that's not the full story. And they're basically saying, okay, well, here's what really happens. Let's talk about that. So back to Mrs. Schrader.
Okay. So your pendulum, you release it, it goes and then eventually comes to rest, and your room is perfectly thermally insulated. How will the temperature of the room change? Okay. So here we would want that it would slightly increase. Okay. So again, as we said, if we were ignoring all air resistance and everything, all of your gravitational potential energy would turn into kinetic to gravitational potential energy, and your pendulum theoretically would continue on. But as it slows down, you are losing some energy to
Mechanical energy.
mechanical energy. So mechanical energy again is potential energy and kinetic energy, all your different types of potential and kinetic. Okay. You would be losing that to thermal energy into the room, and it would slightly increase.
Where
slightly.
Where is the friction for our pendulum?
In the air.
It's maybe a little bit in the air, but even if we did this in a vacuum, we'd get the same effect. Where would there be friction with the pendulum going back and forth? At the top, at that pivot point, all right? There's always going to be a little bit of friction there, and you're going to be warming up that little point where the pendulum is pivoting.
Where the
And
string is attached.
That's where it's turning the thermal energy. And as she said, the thermal energy then goes out into the room. Now, kind of a weird question, because this would be a very poor way to provide heat for yourself in the winter time. The amount that the temperature is going to go up is going to be really hard to measure. But we're doing a, well, technically type question here. So
maybe you have 100 pendulums to warm your room.
yeah, so go ahead and back to what you were saying.
So for part D then, we jump down to there. Okay. Another 3-point part there. Sorry, the scrolling with using multiple devices there. Okay. 1 point for correctly indicating temperature would increase slightly. Another point for stating that you're losing kinetic energy.
You could also say mechanical energy. That
Okay.
would be acceptable.
And then that lost mechanical kinetic energy is converted to heat energy. Okay. So if you just said that it would increase, the temperature would increase because you are losing kinetic energy and you stop there, you'd have 2 out of 3 points. Are we going to do E?
Yeah, we should talk about E. Matt might have, you said you might have needed to fill him in a little bit.
on that?
Yeah, so there's one thing here that you wouldn't need to know for AP Physics 1. And the bottom line is they replace the string with a thin metallic rod or string or something like that. In this question, what they expect the students to know, and this is from the old AP Physics B course where they had thermodynamics, they talked about the expansion of metal due to heat being added to them. And so one thing you have to know here is that the metal gets a little bit longer because of the increased temperature in the room. So from there though,
Okay,
we
from
can
there-
use the physics that we know to answer this question.
So if hypothetically it just said that a student then decided to increase the length of the pendulum, how would it affect it? And that would be a fair question as well. So another pendulum using the metal instead of a string is used in a clock to keep time. The temperature of the room is also to increase significantly. What effect, if any, that? So that is going to increase the length, okay? And if we look at our formula sheet, where we have the period of a pendulum is equal to 2 pi square root of L over G, we should be able to use that relationship to determine that if you increase the length, which is the little L in my equation there, you would increase the period. Okay, so to justify your answer here with your points, you should be writing this formula in your answer. Okay, so correctly indicating that it would increase, so by checking right here. Another point for indicating that the length of the rod increases. That again is due to the temperature in the room significantly being raised, which is going to increase that rod.
Not
Again,
in
that
AP Physics
point,
1, you don't need to know.
Yeah.
So don't worry about whether you got that point or
but
not.
if you could get the first one and then the second or the third one. The third one is again for using the relationship between the pendulum length and the period, which is this right here, to show that an increase in length leads to an increase in the period. Right? So from there, what do we have? 1, 2, 3, 5, 15 points for this one. To the odd scoring. Do you guys at home have any questions?
Question B,
D?
this is just in terms of like the scoring, you technically didn't have to mention the friction aspect, did you?
No, you're okay there. This is D, right? Oh,
Yeah.
wait, D. Oh, I'm sorry, I was thinking E.
You didn't have to say no. It
No,
just
I
says,
was just adding that in there.
Yeah.
You're talking about what I was asking you?
Yeah.
Yeah, you did not have to say that. I'm sorry for causing confusion. I just wanted to explain to you where that friction was actually occurring and where that heat was being produced.
anything else? All right, well, thank you for listening. And if you guys do have any questions after watching this video later, please feel free to email us or bring it up in class, all right? Have a good rest of your day.
Bye. Where's the stuff?